Assalamu alaikum. Microplastic concentrations and risk assessment in various compartments, understanding sources, impacts and future directions, presented by Dr. Adnan Ahmad. Introduction to microplastics. What are microplastics? Plastic particles less than 5 mm in size. Primary and secondary. Primary are microbeads and secondary are degraded plastic debris. Relevance to limnology. Microplastics are emerging pollutants in freshwater ecosystems, affect water quality, aquatic life, and ecosystem services. Objective: explore sources, impacts, and research needs in lakes and rivers. Scope of the issue: microplastics detected in lakes and rivers worldwide. Concentrations vary: 0.1 to 100 particles per liter in surface waters. Significance to limnology: alters physical, chemical, and biological properties of freshwater system. Challenges traditional water quality monitoring. Data gap: limited studies on microplastics in smaller lakes and rivers in Pakistan. Sources of microplastics in freshwater. Primary sources: microbeads from cosmetics, synthetic fibers from textiles, industrial pellets, and abrasives. Secondary sources: degradation of plastic waste from bottle bags, tire water, road runoff, and fishing gear. Pathways: urban runoff, wastewater treatment plants, atmospheric deposition. Transport and distribution. Transport mechanisms: surface runoff, river currents, and wind-driven transport. Sedimentation in lakes and river beds. Distribution pattern: higher concentrations near urban areas and industrial zones. Vertical distribution: microplastics in water column and sediments. Research insight: smaller particles less than 1 mm are more mobile and widespread. Ecological impacts: aquatic organisms, ingestion by fish, zooplanktons and invertebrates, bioaccumulation and biomagnification in food webs. Ecosystem effects: altered nutrient cycling and microbial communities, potential for ecosystem-wide disruption. Case study: microplastics in Lake Ontario fish, up to 20 particles per fish, with some containing over 1000. Human health implications. Potential risks: microplastics in drinking water sourced from lakes, rivers, transfer of toxic chemicals, for example, POPs, adsorbed on microplastics. Knowledge gaps: long-term health effects are poorly understood. Need for standardized detection methods in water supplies. Concern: microplastics detected in 80% of global tap water samples. Detection and monitoring challenges: analytical methods, spectroscopy for identification, and microscopy for size and shape analysis. Challenges: lack of standardized protocols for sampling and analysis, high variability in microplastic types and concentrations. Need automated high throughput detection system. Mitigation strategies: source reduction, bans and microbeads and single-use plastics, improved waste management system. Remediation: Filtration technologies in wastewater treatment plants, biodegradation and bioremediation research policy, global initiatives, European Union plastic strategy, UNEP guidelines, research gaps. Long-term ecological and health impacts, fate of nanoplastics, that is less than 1 micrometer in freshwater system, standardized methodologies for monitoring, future directions, interdisciplinary studies combining limnology, toxicology, and engineering, development of eco-friendly plastic alternatives, call to action, increase funding for freshwater microplastic research. Case study Great Lakes. Great Lakes high microplastic concentrations, 90,000 particles per kilometer square. Sources: urban runoff, shipping and fishing activities. Impacts: ingestion by fish and birds, affecting biodiversity, economic impact on fisheries and tourism. Research: ongoing studies on microplastics transport and sinks. Policy and global initiatives, global efforts, UNEP's Clean Seas campaign, European Union's Circular Economy Action Plan, local actions, community-based cleanup programs, citizen science for monitoring microplastics, recommendations, strengthen international cooperation for freshwater protection. Role of limnology, limnology's contribution. Understanding microplastic dynamics in freshwater ecosystems, developing monitoring frameworks and ecological models, interdisciplinary approach, collaborations with chemistry, toxicology, and policy experts. Future role: leading the change in microplastics research and mitigation. Conclusion. Summary: microplastics are a growing threat to lakes and rivers. Impacts span ecological, human health, and economic domains. Call to action: priorities, research and policy to address microplastic pollution. Foster interdisciplinary collaboration in limnology. Protecting freshwater ecosystem is critical for global sustainability. Clean water is not a luxury, it's a necessary. Thank you for your attention.